So for Avogadros' theory, he talks about the relationship between volume and number of moles. So this means that pressure and temperature are constant when we talk about Avogadros' theory. And he said that the relationship is that volume is directly proportional to number of moles. So we can use the mole ratio to figure out the volume ratio. So here's an example of a balanced equation. We've got 3 hydrogen, 1 nitrogen, 2 ammonia. That's the mole ratio of reactants to products. It's also the same ratio for volumes. So if I had 3 liters of hydrogen gas reacting, I would produce 2 liters of ammonia. So the volume is directly proportional to moles. So we can use those coefficients to figure out volumes of gases. If we look at an example, what volume of carbon dioxide will be produced if 2.3 liters of methane is combusted? So we need to have a balanced chemical equation. So for Avogadros' theory, we always need to write out the chemical equation and balance it. I'm looking for amount of carbon dioxide produced when we combust methane. So methane is CH4 gas. And for a combustion reaction, what's the other reactant? Oxygen. So we have O2 gas. And for a hydrocarbon combustion, we always get the same 2 products, CO2 gas and water vapor. If we balance this, okay, we've got 4 hydrogen in the methane, so we need to put a 2 here to balance the hydrogen. In total, this gives me 4 oxygen on the product side, so we need a 2 here to balance the oxygen. So the ratio, the mole ratio, these are 1, 1, 2, 1, 2. This is the same as the ratio of the volumes reacting because V is directly proportional to number of moles. So we can use the mole ratio to figure out the volume ratio. To do this, we're going to take 2.30 liters of CH4, and I'm going to solve for liters of CO2. We have to use the mole ratio to figure this out. So an easy way to remember when you're setting up a mole ratio is that your unknown, so the thing that you're solving for, I always remember unknown goes up in the numerator. So U and U. So the one that we're looking for is the one that needs to be in the numerator. So we multiply this by moles of CO2 divided by moles of CH4. So my unknown is the CO2. Now we just substitute in the mole ratio, which is the coefficients. So I have 1 mole of CO2 per 1 mole of CH4. If we look at our units, moles cancel, CH4 over CH4 cancels, so we're left with liters of CO2. Because it's a 1-to-1 ratio, the volume of CO2 that we're going to produce will be equal to 2.30 liters. Oops, and I wrote liters twice. 2.30 liters of CO2.